Welcome to another interesting session from Cloudnloud Tech Community's mini conference 2022. Today, we are going to see various topics like Azure Cognitive Services, Azure Web Application and Load Balancing using Traffic Managers, unit testing without any mocks, and serverless AWS. So we are going to have a lot of speakers here. First of all, let us see what we are going to be having for today's session. As I said, we will be having a lot of speakers like Yasmin Sheikh from Australia, Bharat S, Shruti G Kinney, and Neha Gupta from India. So they are going to speak about various topics, as I said, about Azure, AWS, cognitive services, and unit test without writing any test cases. Without any further ado, let us go inside and welcome Yasmin Sheikh.
Hello everyone, welcome to our Cloudnloud first mini conference. Thank you all for joining us today. Okay, so I hope you are enjoying all the sessions related to DevOps and the cloud technologies that is hosting in our conference today. I hope you learn a lot. So if you get any questions, please do keep posted in our LinkedIn group, and also please do post your questions in our GitHub repository as well. I will show you where you need to post your queries. So you can, if you have any queries in regarding to this session or in regards to any other session, you can post your queries there. Okay, so Cloudnloud is having 11 plus years of experience in training professionals across various technologies like DevOps and cloud technologies, automations, and many, many more. So if you have not subscribed to our newsletter, please do subscribe to our newsletter so that you don't miss any updates. And also we will be posting many job openings, all those things in our newsletter as well. And if you are not subscribed to our YouTube, please do subscribe so that whatever the upcoming sessions that we are going to be hosted, you will be notified accordingly. Okay. So thank you. Let's get started in today's session. So before starting, let me share my screen. Okay, I hope you all can able to see my screen. So I just wanted to show you this is the Cloudnloud GitHub in where you have a repository called Tech Queries. If you go into that, if you go into the issues, if you have whatever the new issue or whatever the queries you have, please create a new issue and post here so that any one of us from the Cloudnloud Tech community will make sure to answer you. Okay. Yeah, so today in this conference, I'm going to talk about one of the Azure service that is called as a Azure Traffic Manager profiles. Okay, and I'm going to show you how you can deploy your Azure web apps, and also I'm going to show how the traffic can be diverted to the different virtual machines based on the load. Okay, let's get started. Okay, so before starting the session, I wanted to give a short introduction about myself. I am Yasmin Sheikh. I work with Cognizant Technology Solutions, Australia, and I have a 6+ years of IT experience in DevOps technologies. Okay, and also I am an Azure evangelist in Cloudnloud Tech community. So let's get started with the Azure service today. So before telling you about the Azure Traffic Manager, I want to let you know, as you know, that Azure Traffic Manager is obviously one of the load balancing method of the that is provided by the Azure, right? So why do we need the load balancer at the first place? So if we don't have the load balancer, what is the what is the failure that we are going to experience, right? So this Azure load balancer will make sure to distribute your workload, whatever the workload you're giving or whatever the traffic that is coming to you to use your web application that is hosted on your web servers, that will be equally distributed among your computing resources, right? So if you don't have any this load balancing techniques in place, then whatever the traffic that is coming, that might hit to one resource, and it might cause that resource to be overloaded and it may go down, right? So which indirectly affects your customers experience. So we need Azure balancing for distributing our workloads in a proper way, so that no resource can be left unutilized and no resource can be overutilized, right? So in overall, Azure is offering you usually four of the methods, four of the Azure balancing technologies. So you can go ahead and use any one of them. Okay, so the four loading balancing methods that Azure Azure is offering you, that is Azure Front Door, Azure Traffic Manager, Azure Application Gateway, and Azure Load Balancer. So you might be thinking about which service, which technique or which method you wanted to use during which time, right? So it depends on your application, it depends on your requirement, and also it depends on your specifications, how you wanted to design your application and which users do you want to access your application as well. Okay, so if you think that if your users are going to, if your application is going to be like public facing, then and if you expect that your application is going to be getting the HTTP or HTTPS traffic, and also you need to decide whether your application is going to be hosted in particular one region or it's going to be globally utilized. So based on all these scenarios, you will be deciding which load balancing method or technique that you can use for your project. Okay, as you can see here, you can use the Azure Front Door if you want to host your application. If you want to enable the load balancing globally, and if your recommended and your expected traffic is HTTPS. Okay, in the same way, if you are if you want to host your application globally, if you want these load balancing solution globally and your expected traffic is non-HTTPS, then you can go with the traffic manager. In the same way, this Azure Application Gateway and Azure Load Balancer, it is utilized not for the overall globe. It can't be used globally. It is particularly for one particular region. Okay, so if in one particular region, if you want to manage the load, if you want to divert the load to one virtual machine to another virtual machine, then you can use this application gateway as well as a Azure Load Balancer. Okay, this application gateway will be managing the load at the application layer level, whereas this Azure Load Balancer will be managing the traffic and distributing the load based on the network level network layer. Okay. So I wanted to give you a short overview of this is the actual. So let's say if you are the architect of your project, okay, if you have to provide the solution to your project and you have to provide the solution, which load balancing technique that you are going to implement in your project to handle your workload easily, right? If as being a solution architect, you should be careful about choosing the applications which you wanted to host. So for example, this is one of the architect plan. If you have satisfying all those conditions, you can select your load balancing accordingly. Okay, let's say if you are you have a web application. Okay, you have to consider whether your web application is going to be public facing or private application, like only the authorized users of internal your organizations only they are going to use, or the application is the public which anyone with the internet can use your application. So you have to decide whether your web application, which traffic is going to be hitting your web application, like HTTP or HTTPS, and also you need to decide whether your application is going to be public facing or a private facing, and also you need to decide your application is going to be deployed globally or it's going to be deployed in any particular region for any customers of that particular region. And also you need to decide whether do you want to enable this SSL offload or not. So based on the SSL offload is nothing but a network priority, network link that is specifically created into one virtual network between your virtual machines or between your virtual machine scale sets. Okay, based on all these scenarios or all these specifications, you have to decide which load balancer you have to use. For example, as is shown in this architecture diagram, you can see once the web application is coming, if it is not a HTTP or HTTPS, if it is an internet facing application, public facing application, and if you want to deploy it globally, then you can select traffic manager along with the load balancer. So one more thing I wanted to let you know is you don't need to use only one particular load balancing method. So based on the solutions, you can combine in these four load balancing techniques to implement your solution as well. So like this, if you as you can see here, if your application is going to be deployed globally, then you can use along with the traffic manager, load balancer along with your traffic manager. If your application is not going to be deployed globally, and if you're only going to deploy in only one particular region, then you can deploy then you can use only Azure Load Balancer. Likewise, if your application is web application, and if your application is not a public application, I mean if it is a private application, then you can use the application gateway. If your application is a public application and if you want to deploy it globally, and if you want to enable SSL or not, based on that, as you can see here, based on that you can choose your load balancing techniques. Okay, so this is the overview of the plan. So if you are an architect, you can choose your project, I mean load balancing solution for your project based on this architecture plan. This architecture plan is provided by the Azure itself. So you can go and see in your Azure website, or you can come to the Cloudnloud GitHub, where I have mentioned all this step by step process. You can go there and find this architecture plan as well. Okay, you can see this and you can implement the same as like in your project. Okay, now let's get started with the Azure Traffic Manager. So out of these 4 load balancing techniques we have, Azure Load Balancer, Azure Application Gateway, Traffic Manager, and Azure Front Door, I'm going to explain about the Azure Traffic Manager today. Okay, let's see about that, and we will see how we can deploy our virtual machines and how we are distributing the load among them. Okay, so the main advantage of I can say that one of the advantage of going with this traffic manager profiles are it increase the application availability. For example, let's say if your application, if you have deployed in application in one region, okay, so and also you are deployed application in the other region, this Azure Traffic Manager will monitor your clients. I mean, whatever the regions are you have connected with this load balancer, it will check the status of that particular virtual machine or that region. It will make sure if something is down in that region, it will make sure to divert the traffic to the other region, so that whatever the customers they are trying to access your web application, they actually don't see any issue with their accessing your application. Okay, in the same way, the other advantage is improved application performance. That means, let's say I'm accessing that web application from Australia. Okay, so you have deployed the application globally in Australian region, in Asia region, in US region, all those things. So if the people accessing from that particular region, it will direct the traffic to that particular region virtual machines, so that they can be served easily without any latency delays. Okay, so you don't need to the traffic don't need to travel a long distances, so it will make sure whatever the client, I mean the request that is coming from the region, it will direct the traffic to that nearest, or if you have the web application in that particular region, it will serve from there itself. Okay, that is one of the another advantage. And another advantage of going with this traffic manager is service maintenance without downtime. For example, if you want to if you want to apply some maintenance, and if you want to complete the maintenance on your virtual machines, then what you can do is, even though your one virtual machine or one region is down, this load balancer will make sure to direct the traffic to the other regions, so that you will be served without any issues. Okay, in the same way, the other advantage of going with this Azure Traffic Manager is hybrid applications. Hybrid applications means, so when the traffic is coming, if you not only the Azure, if you have application on your own on premises, let's say, so if you have applications in on premises and we have attached it to the load balancer, so then this load balancer will make sure to distribute the traffic not only to the Azure regions, and also it will make sure to distribute the traffic to your on premises applications as well. So you can integrate both your on-premises and both, as well as the applications in your Azure itself. Okay, it supports both. Okay, so before starting this Azure Traffic Manager, let me tell you about the main point about this Traffic Manager. This Azure Traffic Manager actually distributes the load among the different resources using their DNS. Okay, this is their DNS-based traffic load balancer, which uses the DNS of the client or the endpoints. It uses the DNS of the endpoints, and it will distribute the load across that endpoint easily based on the DNS you have provided for that endpoints. Okay, we will see this in detail now with the hands-on, so you can better understand. Okay, now let's go to the Azure portal. So this is my Azure portal. So first of all, to show that, I'm going to create one of the virtual machine. Okay, I'm going to the all resources, and I'm going to create one virtual machine. Okay, So as I don't have any resource group, I'm going to create one new resource group. Okay, so I have already explained in detail about each and every tab and what the options that you need to be selecting while creating virtual machines based on the requirements do you have. So please, you can go ahead and watch this session I have already given in the YouTube channel, in a Cloudnloud YouTube. As of now, I'm just going to create one of the virtual machine. So I may not be able discussing this in very detail, but I will show you how you can create a virtual machine, how you can deploy it as a web server, and how you can use it. Okay, so now I have created one resource group that is called as a RG1. Now I'm going to give my virtual machine name as a server1. Okay, and I'm going to host this application, this server on East US region. Let me search for East US. Okay, so I'm going to host this server on East US region. Okay, I don't want any availabilities, so I have just disabled, as I don't want any redundancy. Okay, so now here you can select any image of your operating system based on that are available in the Azure marketplace. So there are many products that are available here: Windows, you can choose CentOS. So Windows and Linux both, there are many flavors that are available here. You can choose any that you are wishing to. Okay, so I am planning to go with Rocky Linux. Okay, I will go with the Rocky Linux 8.5. So I have selected my image. I'm going with the size. If you want to change the size, go to see all sizes and you can change the size. As I want to just show you the demo, I'm going with the basic instance, which is BS1. Okay. So now, if you, as you are using a Linux machine, if you want to go with creating a private and public keys, you can go with here and create one. But if you want to go with username and password to log in into the virtual machine, you can do that as well. So I'm going to use my username and password. I don't want to go with private and public keys as of now. So I'm just going to give one username. Okay. I have given my password. Okay, I have given my password now. In the disk, so there are three options you have. Premium disk is useful for the production purposes usually, because it provides the high throughput and the high IOPS when compared to the other selections. But if you want to just practice, or if you want to use for the dev or test purpose, you can go with the standard SSD, or it's non-critical. If you are having a non-critical workloads, then you can host with a standard HDD. Okay, as it's just a demo, I'm going with a standard HDD. Okay, I'm not changing any encryption types for that. So network, so when I'm creating the virtual machines, this network is automatically getting created in my region, in my resource group which I have provided. Okay, I have not created it, as I don't have any virtual networks already available in this resource group or in the region. It has automatically picked up one virtual network. Okay, I'm going with the same network. Okay, I'm not enabling anything here. Okay, I'm not doing anything here as well. So let me go advanced tags and review and create. So it validating your all the prerequisites that you have given. If it gets success, it will start creating. Okay, let's wait for the validation to get success. Okay, the validation is passed now. Now I'm going to create my virtual machine. So I have done nothing. I have just created one of the virtual machine using the Rocky Linux operating system, and I'm going to make it as a web server. Okay, so I have started the deployment. So meanwhile the deployment gets finished, I wanted to show the load balancing, right? So I'm going to create another virtual machine as well. So I'm going to open the other window. Yeah. So now let me go ahead and create one more virtual machine. Okay, we go to create virtual machine. As I have already created one resource group, I'm going to use the same. This one I'm going to name it as server 2. And this time I'm going to change the region because I wanted to show you how the traffic manager actually send the client request to the different resources that are placed in the different regions. Okay, so that's why I'm going with the another region. So when creating the last virtual machine, I have gone with the East US, right? Here I'm selecting the West US. Okay, I don't want any redundancy, so I'm leaving it as the same as the image. I want a Rocky Linux, so I will be changing my operating system image. If you want, you can choose anything you want here. Okay, I'm going with the Rocky Linux. Okay. Rocky Linux. Yes, select this one. Okay, so probably it's not displaying, but it has selected it. I will show you when it is getting created. Okay, so the size, I'm not changing anything. I'm leaving it as it is. So I want the username and password here as well. So I'm going with my username, admin user, and I'm going to set my password to log in into this virtual machine. Okay, so here also as just a demo, I'm going with the standard HDD. So as you see here, as we are creating this virtual machine in the same resource group, but in the different region, right? I have chosen the same resource group RG1, but I am creating this virtual machine in the West US region, right? So that's why it has created in the same network, but it has allocated a different subnet to this virtual machine. Okay, I'm not going to change anything else. Sorry. Go to the management, go to advanced, review and create. So it will validate your virtual machine and it will create your virtual machine. Okay, let's wait. Okay, create. So the second virtual machine deployment is also started now. Now let's go back to our first resource. If I go to the notifications tab, as you can see here, my first virtual machine has created. Now, if you click on the go to resource, it has taken me to my server 1, which was created in the East US region, as you can see here, right? So now this is the public IP address of my virtual machine. If you want to connect the console of this server, you can directly go to the Bastion service available here in the portal itself. You can deploy this Bastion service. This Bastion service is useful for you to get the console of this virtual machine in the browser itself. Okay, but it will take some time. But if you want, you can do like this as well. Okay, meanwhile, let's see the status of our second virtual machine. It's still in the deployment. Okay, let's come back. So I have enabled the Bastion service. Let's see. Okay, so what I will do is until my second virtual machine gets created, as my first virtual machine is already available and as it's taking some time, I'll go with the PuTTY. So you can connect to the console of your Linux virtual machine using PuTTY or Mobile Extreme, whichever the tool you're comfortable with. Okay, so I have already PuTTY in my laptop. I mean, as I was already using it, I'm going with that. Okay, so we need to provide the public IP address, which we have got in the Azure portal here. So copy that public IP address, paste in the PuTTY, and connect it. Accept. So it will ask you for login. So provide the credentials which you have given while creating this virtual machine. Okay, so I'm giving the same credentials. Now I have logged in into my console of my first virtual machine, which is a server 1, as you can see here the name. Okay, let us see. Our second virtual machine is also deployed now. Go to this, as you can see, server 2. So this is the public IP address of my second virtual machine, which is hosted on the West US region. Okay, so what I'm going to do is I'm going to connect the console of this second virtual machine as well. As I shown you, if you want, you can go and enable this Bastion service to access this console in the browser itself, or as it takes some time, I'm going with PuTTY as PuTTY itself. Okay, so I'm going to copy the second virtual machine's IP address and I'm going to paste in my PuTTY. Open. So now accept. I'm going to provide the credentials which I have given while creating this virtual machine. Okay, so we have now created two virtual machines and we have we are accessing the console of that two virtual machines now. So as of now, it's just a virtual machines. We have not set up any role to this virtual machines, right? We have not made it as a web server or a web server role to this. We have not applied this web server role to this virtual machine. We have not applied or we have not installed our web server yet, right? It's just a plain virtual machine. You can set up any role you want. You can set up it as a database server. You can set up it as a web server. You can set up it as however you like. Okay, so as I want to show you how the web server is deployed and I want to show you the traffic management. So I'm just going to set this role as a web server. Okay, let me go to my server one. So this is the console of my server one and this is the console of my server 2. As you can see here, the name. Okay, so now once we have logged in, let me go as a sudo user, because whatever the commands that you are going to execute, so I'm going to do as a root user, super user. Okay, so that's why. Okay, so now I can execute any commands here. So when you have actually selected your image for the operating system, along with your image, there will be some packages like there will be some application packages that will be automatically got deployed with your image itself. Okay, so what I wanted to do is I just wanted to install one of the web server application. So now I'm going to install Apache server Apache server application here, Apache server service here. If you want to use Nginx, you can do that as well. Okay, so I am okay with installing this Apache server, so I'm going to install that. So install httpd -1. So if you want to install the Nginx, so give the same command as yum install nginx. So nginx. Okay, so you can give the same like installing the Nginx web server. As I want to install the Apache server, I'm just going with the httpd. Okay, just give enter until it installs. Let install the same in our virtual machine 2 as well. Okay, so now our virtual machine, we are downloading one of the web server application onto our virtual machine. Okay, sorry. Let's wait for a few minutes. It will take approximately like 2 to 3 minutes to install your application. As you can started here in the server one, it's installing all the required streams, and it's installing my Apache server application. Okay, let's wait for 2 more minutes. As you can see here, our server 2 is also started installing the web server now. Okay, so our web server has successfully installed on our virtual machine server 1, right? So now what I'm going to do is I'm going to start server. Enable HTTPD. So this I'm going to enable this Apache server service. Okay, I have enabled it now, and I'm going to start HTTPD. Okay, so you can just give as a systemctl enable HTTPD. So HTTPD is used for any Red Hat enterprise Linux distributions. So the Apache server service is mentioned as a HTTPD here. Okay, so systemctl enable HTTPD will actually enable your HTTP Apache server service. In the same way, if you want to start the service, you can give as a systemctl start HTTPD. Okay, it will start your service. In the same way, I'm going to do the same in my mission 2 as well. Okay, so now in the mission 2, we have our app server installed. So now I'm going to enable HTTP. Yes, enable it. And now systemctl start HTTPD. So now I'm starting with app service. Okay, so now I have installed the app server and I have started that service on my Linux virtual machines. So if you are using the Windows virtual machine, what you can do is you can directly go and RDP that virtual machine, and you can go to the Google Chrome browser or Internet Explorer. So any virtual machine that you are creating, that will be automatically connected with the internet. So you can go and download the required packages, required application from the internet itself, as you normally do in your laptop. Okay, so and also if you want to set up that virtual machine, that Windows virtual machine, as a web server using the IIS, Internet Information Services, then you can find it in the default servers in the server manager. If you want to, if you go to the roles and uh, if you want to go and set up the roles, then that web server IIS is automatically will be available to you on the Windows operating systems. Okay, so as I have taken this Linux virtual machine, like this, we have to install whichever the web application you wanted to. Okay, I have installed this Apache server here. Now I've started the service, done. So, but I don't have anything here to see whether my service has started or not, right? So what I'm going to do is, I'm just going to check systemctl, tell me the status of uh, my service. This HTTPD. If you click here, as you can see, active. So it says it's running and it shows it has started this Apache HTTP server. In the same way, I'm going to check the status in my virtual machine one as well. Systemctl, tell me the status of my app server. As you can see here, it is also active and running, and it is also shows that it has started the Apache HTTP server. Okay, so now we have installed and we have started the service, and our virtual machines are up and running as a web servers now. Now what we will do is, okay, so what I'm going to do before that is I'm going to disable the firewalls, because when you want to use these virtual machines data from the outside, from the public your internet, so there might be some firewalls which is going to stop accessing this. So what I'm going to do is I'm going to disable the firewalls. Systemctl disable firewall the semicolon. If you want to give the multiple commands, just use the semicolon. So, and the other command I'm going to give is systemctl stop firewall. So I'm disabling and stopping the firewall services on this virtual machine. Okay, I just want to do the same here as well. Okay, so I'm going to systemctl disable firewall and also stop firewall. Okay, so I have disabled and stopped the firewall on my both of the virtual machines now. So I'm going to echo some of the message on my server one, because I wanted to show you the difference between while the traffic is routed. I wanted to show you how the traffic is getting routed to server one and also to the server two. Okay, so because of that, I'm going to echo some message here on the server one. I'm going to mention as echo. What I wanted to echo. Okay, let me tell it as let's say learning is learning is the learning is the key to success. Let me host this message, and I want to redirect this message onto my root directory where www html and index.html. Okay, I want to redirect this message onto my root directory in this file. Okay, and I'm going to give the same echo. Message I wanted to give in my second server is I wanted to give some other message because I want to show you that difference. Let me give you as a um, don't give up even you fail. Okay, and let me redirect this also onto the root directory of that same virtual machine. Okay, I'm going to do the same. Okay, so I have echoed some message. I have echoed one message which is called as a learning is the key to success on my server 1, and I have echoed another message which is called as a don't give up even you fail, that is on my server 2. Okay, now we will see how we can access this. I mean, how the public can access our virtual machines and how they can. So usually once these app servers are installed, the developers can go and host their web applications onto this web server so that whatever the users going to access these DNS or the public IP address, they will be seeing your application or the web page that you have designed and hosted on these web applications. As I don't have any, I have just echoed some sample message to show you the difference, and I'm going to give this in the load balancer. Okay, so now we have created two virtual machines. We have installed the app servers and we have started the app servers, and we have echoed some message to as a sample. Okay, so now let me minimize both these consoles. Now this is my server 1, right? Now I'm just going to create one load balancer, which I'm going to use this time as a traffic manager. Okay, so if you can search as a traffic manager, so you will get one service that is called as a traffic manager profiles. So click on that. So as I told you earlier, so Azure is actually offering a 4 types of load balancing techniques, right? As you see in the left pane, it has application gateway, front door, load balancer, and the traffic manager. So you can design any one or a combination of any based on your requirement or based on your specifications of your application, as I have shown earlier. Okay, so now as I wanted to show you the example of the traffic manager, I'm going to create one of the traffic manager instance. Let me go ahead and click on create. Here, give your name, give some name to your load balancer. I'm giving as LB load balancer. And this is the routing method. So routing method, you can decide whichever you want. I will explain you how you can, what it's actually doing when you select what. We will explain, we will discuss in some time. As of now, I'm just going with, let's say, priority, and I'm choosing the same application. I'm going to choose my resource group. Okay, and I'm going to create my traffic manager. This is actually very simple. If you want, you can go ahead and try in your own POC lab and see how the traffic is distributed to the different virtual machines that is in the different regions. And also you can use the other load balancing techniques, how the traffic is distributing among your virtual machines or among your virtual machine scale sets, using those virtual machines, which is applicable to the regional level as well. Okay, now I think our deployment is success. So my traffic manager, which I have given a name as a load balancer LB, has created now. So now if I go to these endpoints, so now if I click on add, I can go ahead and add my virtual machines. Whichever I have created in the different regions, I can add my virtual machines here as one of the endpoint. Okay, so but before doing that, as I told you earlier, Azure Traffic Manager is a DNS based load balancer, right? It can access or it can distribute the load only using your DNS of that particular endpoint. So if you remember, we have not selected any, we have not set it up any DNS here, right? So this is the server 1. If you go to the overview tab, you will be having an option called a DNS name, which is not configured here. So if you click on that, you can choose any one of the name. Let's say I'm going to give it as server 1. Yes. Okay, so I'm giving it as server1 as and save. Okay, so in the same way, I'm going to my server2 where the DNS is not configured. So I'm going to configure because this load balancer is going to use or redirect the traffic to these virtual machines only based on the DNS because it's a DNS based load balancer. Okay, so let me give that server2. Yes. Okay, probably it has already utilized. Already available. I have given some name and I'm saving it. Now let's see. Yes, our public IP address, the DNS has set it up. Okay. Now, if you go to this, your server one, and if you go to the overview, refresh. As you can see here, earlier it was like not configured, right? As you can see here, now it has one DNS, which is called as a server1 as, which I have given a name. You can do your dynamic or static DNS based on your requirement. Okay. So here, let's see whether the server2 has created. Now it's done. Now let's go back to our server2. So it's not showing. Let's refresh. And it should show the DNS. Yes, right. So as you can see, this is the server 2 and its DNS is set up now. Now I'm coming to my load balancer and I'm adding Azure endpoint. Okay, so I'm adding an endpoint. I'm going to give that name as, let's say, server 1 because I'm going to add my server 1 first into the load balancer. So as your target resource, you can choose the app service, you can choose this cloud service. If you have the app services created in your Azure portal, you can choose the app service and you can add your app services. So this load balancer will make sure to distribute the traffic to your app services. Because I don't have app service, I have created the virtual machines from the base, so I'm going to use this public IP address. Okay, so if you scroll down, this both server 1 and server 2 IP address is showing here, so I'm going to select server 1. Okay, here priority you can give it as a 1 or 2. Okay, I will tell you what is that priority and how it will act. Okay, let's see in some time. As of now, I'm leaving it as a 1. Okay, remember that. So go ahead and add. So I have added my server 1 to my traffic manager, which is a load balancer. Okay, so now its priority is 1. Now I'm going and adding my second virtual machine as well. So I'm giving a name as server2. As it's also not an app service, it's just a VM server I have created. I'm going to choose a public IP address. And here, as we have already added server 1 IP address to this load balancer, it's now showing only the server 2. So go ahead and select that. So it automatically has taken the priority as 2. So I'll tell you why. And now I'm going to add this endpoint as well. Okay. So now our both virtual machines has been added here. Now if you refresh, it's still checking the endpoint status. This load balancer, this traffic manager is also monitors the health of your endpoint, and if anyone is down, then it will automatically redirect your traffic to the other endpoints available. Okay, it's checking the status of the endpoint. It has not detected it. Okay, so until then, okay, so if you remember, while creating the virtual machine, we have not actually enabled the HTTP port for network security group to access the traffic from the public internet, right? So because we have set up these virtual machines as a web server, so to access your web server, your port 80 should be enabled so that any HTTPS traffic should be able to access that your web server. Okay, so but while creating this virtual machine, we have not allowed the port. We have just allowed the port of SSH22. So as you can see here, this is your server. Come to the networking. As you see here, this is the network security group that is enabled. So this virtual machine will allow the traffic to your virtual machines only through these ports. As you can see, only SSH port 22 is enabled. But as being a web server, to access that web server, you need port 80 to be enabled, right? So I'm going to add one rule. Let's say I want HTTP traffic to be allowed, and I'm going to name it as a port 80. So what I am doing is I am adding a port 80 to my virtual machine server 1. The same way I'm going to add to my server 2. Go to the server 2, go to the networking. If you see here also only SSH port 22 is only enabled, right? So now go and add inbound port rule. I want to allow HTTP, allow or deny, so I want to allow, so the same. And if you want to give some name, give it, that's it. By this, you are allowing the traffic to your virtual machines through the port 80 as well. Okay. Done. So we have added the rules. Now let's see our load balancer. Okay, can you see why it has showing it as a degraded? Because we have enabled our virtual machines. I mean, we have enabled the port 80 just now, right? It has not applied here there yet. So let us wait for a few minutes until it detects actually the status of your virtual machines. Okay. So to do that, to happen that fast, as it's a demo, I'm just going into the configuration into my load balancer. I'm just reducing the interval here. So this probing interval will tell you how fast it should detect the status of your endpoints. Okay, so I'm going to reduce this interval so that it detects my virtual machines very fast. Yes. Okay. Save. Done. So now, as you see here, now it has detected our virtual machines is online because we have allowed that port 18 now, and I have reduced the time to detect to get the status of that virtual machines as well. So it shows the online now, right? So now, if you go to the overview of the load balancer, this is the DNS, this is the URL, right? If I copy this URL, if I go and paste in my browser, this is my browser, okay? This is my laptop browser, which it's like I am now a public user who trying to access that web application, which that URL. So if you see here, it has directly redirected me to the server 1, where I have echoed the message as a learning is the key to success, right? Likewise, if your developer is going to host their web applications, that web application or that web page will be displayed to the user here. So I just wanted to show this. So I have not done anything. I have just copy paste the URL of the load balancer. It directly redirected to the server 1, right? I will tell you why. Now, if you come to your load balancer, if you come to the configuration, so if you remember, while creating this load balancer, we have selected this routing method, right? I have selected the priority one. What happening with these different routing methods is, so if you select this priority one, it means that, so in the endpoints, so you have, while attaching these endpoints, it has asked you to give the priority, right? I have given this as a 1, I have given this as a 2. It means that whatever the traffic that is coming through the public internet, that will be priority, as it is having a priority 1, that will be sent to your server 1. So once your server 1 is having a full capacity, or it has reached the maximum amount of limit, then your traffic will be redirect to your server 2. But usually in the production, all your servers will be hosting the same web application, right? So your user won't see any difference which application or which server they are accessing. To show, I just wanted to show that difference to you. That's why I have given or echoed the different messages here. So likewise, if I have a 1 and 2, right? So now as the server 1 is having a 1 priority, that's why my direct, when I am giving here, when I am searching through the URL, it's directly taking it to me server 1. So now what I want to do is, now let me go to this server 1 and stop this. Let's say my virtual machine is down, or let's say some my virtual machine has the region where my virtual machine is hosted has gone down completely. Okay, so what I should not do anything. My load balancer should be able to detect the status of that server going down, and it should directly redirect the user to the next available server, which is server 2, right? So now let's wait until this virtual machine server 1 gets stopped. Okay, it's running. So meanwhile, I will explain you what are the different routing methods. Okay, so if you go to the configuration, priority is something like, based on the priority, the traffic will be sent to your virtual machines. Okay, if you want to go with the performance, it will detect which virtual machine is having a high performance, so the traffic will be sent to the high performance server first, then the low performance based on that. Like that. So based on that, a priority, based on that, it will distribute the traffic. If you want to go to the weighted is nothing but, let's say if you have 2 or 3 virtual machines, then your first request will be sent to your server 1, second request will be sent to your server 2, your third request will be sent to the server 3, again fourth request will be sent to the server 1. Like that, it will distribute the incoming request to the different servers at the same amount of time. Okay, it's distribute. You can do that with weighted one. And the same way, as we have seen now, priority. So whichever the priority we have set, based on that priority, it will send the traffic to that virtual machine. Likewise, if you want to select the geographic, so you can, well, if you want to go to the geographic, you can select the geographic area which you wanted to give to that particular endpoint. What happens is, so for example, if I have given the geographic area as Australia, then the people whoever accessing from the Australia will be served first. Then only the people from the other regions will be served. So based on these routing methods, whatever you require based on your requirement or specifications based on your applications, you can select your routing method. Okay, I'm not going to change anything. I'm just going with the priority one. So I have just wanted to explain about that. So let's see if our virtual machine 1 has stopped. So yes, the status is stopped and delocated now. So now if you come to your load balancer and refresh it, it should be able to automatically detect that our server 1 is down now, right? Go to the endpoints. As you can see here, our server 1 has degraded because it has stopped and it has not available now. So now, even though still the priority 1, but it is degraded, this load balancer should be able to detect that and should be able to send your traffic to the server 2, right? So this is the URL which I have copy pasted earlier of the load balancer, right? Let me go and refresh this. Can you see? It has automatically taken me to the second server where I have echoed the message as don't give up even you fail. So like this, it will make sure based on the endpoints status and their health status, and it will continuously monitor whether it is online or not. Based on that and based on the routing methods you have selected, it will distribute your traffic among all the virtual machines, among all the regions or in the same region you have chosen. Okay, so this is the one of the example based of the traffic manager. So what I have done is, if any one of you have wanted to create these virtual machines, and if any one of you wanted to try this, you can go ahead and try this. If you wanted to know that commands which I have given in the virtual machines while installing the web server, and if you wanted to go by step, I have already make a note on Cloudnloud GitHub as well. If you go to the Cloudnloud GitHub, you will be finding one repository. I have made it as a public. This is the Azure Traffic Manager. If you go inside that, if you go to this file, you will find a step-by-step process. You can follow that as well if you wanted to try in your own lab. Okay, I hope you have enjoyed today's session. I hope please try in your own POC lab and let us know in our comment section, or also please let us know in in our Cloud and Love LinkedIn group how you have got, what are the challenges you have faced and how the answer, how the output was for you. Okay, so I hope you have enjoyed the session today. Um, Please stay tuned in to our Cloud and Loud channel because we are going to bring more initiatives and I'm going to take more sessions on Azure DevOps and more Azure services, which will be useful for you. So please stay tuned to our Cloud and Loud channel. We are going to host many technical sessions in the future. As I told you earlier, please do subscribe to our newsletters and the YouTube channel. And please stay tuned our Cloud and Loud. We are going to bring more sessions on the Azure services, more live sessions, so you can do with us and you can discuss with us and we can discuss among ourselves and we can do if any issues you are facing we can do and we can fix it as well. Okay, please don't forget to post any queries you have in our Cloud and Loud GitHub repository which I have shown you earlier. And until then, take care. I'll see you later. Bye.
So thank you, Yasmin. That was really an awesome session on web applications in Azure and also how to manage the traffic. It was very well explained. Looking forward to more sessions with you from Cloud and Loud Tech community. Now we will be having a small game here. So what we are going to do over here is we are going to play from Kahoot. I'll share my screen so that you can see what is it. I hope you all had a wonderful session. So please do let us know what is happening. I have now started the screen share. You can see that there is a game pin getting loaded. So what happens here is you need to log into kahoot.it, www.kahoot.it, wherein you will be asked to enter the game pin. Once you enter the game pin, we can start the game and there will be a lot of questions that are being asked on Azure and certain topics inside Azure. So be ready, and once we start the game, the prizes are really interesting and exciting. So I'm just hoping to see many of you joining the game. I will also post the pin number in the comment section so you can directly go to kahoot.it, enter the pin and join the game. Once we have players, we will be starting the game. So we have our players here. I will be starting the game in another 5 to 6 seconds. Welcome Subhash and Thameen. So today's game is about Azure architecture. For those of you who have joined just now, you can see the game pin on the right hand side bottom corner of the browser. The last question for this session. So here the winners are being calculated and they will be displayed on your screen. All the winners, please be careful. We need a screenshot of this particular browser or this particular page on your phone, and please email it to info@cloudnloud.com with the track with which you have attended this game to win the exciting gifts and vouchers from Cloud and Loud Tech community. Thank you so much, guys. So now this is done, we will be moving on to our next speaker. Our next speaker is Mr. Bharat, and he will be speaking to us about serverless architectures with AWS. Bharat is having his own YouTube channel and he has been doing a lot of work to the community. Feel free to get into touch with him in his LinkedIn profile. Over to you, Bharat. Thank you.
Hey professionals, my name is Bharat and I'm currently working as a senior cloud engineer for Deloitte Consulting. My core responsibility or my core work the core contribution I do at Deloitte is basically, help adopt and accelerate the client journeys to the cloud. So I'm a cloud migration consultant, cloud modernization consultant, and also a cloud and also a lead of cloud product management, right? So basically, in terms of migrating the 6-star dispositions, and also sort of bringing the workloads from on-prem or from different cloud to a desired cloud, and probably modernizing it to a containerized level, with completely transforming the sort of architecture from monolithic to microservices is my core expertise. And I'm super glad to be in the cloud and cloud technology event. Thanks a lot for everyone. Thanks a lot for the whole team for making me to this, for making me a part of this opportunity. I would love to share my core insight, for which I'm extremely bullish on the next phase of cloud computing. So thank you very much, folks. Let me kickstart my session. So today's webinar is going to be serverless architecture with AWS. In this arena of cloud and DevOps, right? There is this huge buzz about serverless architectures and serverless architectures with AWS, serverless architectures and FaaS, function as a service, and also basically you just completely all the serverless applications in AWS GCP, and you have cloud functions in GCP, you have Lambda in AWS, and you have functions in Azure, right? What is this? Is the serverless architecture, the serverless computing is the next phase of cloud computing. So today I'm gonna throw some light on how you can build serverless architecture with Amazon Web Services. So basically, I'm gonna throw some light on the innovations the AWS has and how to leverage those innovations to build a serverless architecture for a 3-tier application or a multi-tier application. So today's agenda or the objective is, I would first explain how to use serverless architecture in a 3-tier applications, and then using AWS Lambda, AWS API Gateway, and other services. So basically, I'm going to explain how to use, how to basically, sort of build a serverless thriving architecture for this microservices in a containerized world with the combination of AWS Lambda, which is the function as a service of AWS, and Amazon API Gateway and other services to implement this whole serverless architecture. And I'll also explain the common patterns for serverless applications. What are the common patterns that are that are basically existing in the software development, and also how I'm going to explain. I'm going to end this webinar with a wonderful case study of how Coca-Cola as a company leveraged AWS stack, that is AWS Lambda, API Gateway, and AWS database services to build a serverless architecture for its vending, for its coke vending machines, and thereby reducing the cost by 70% and completely and completely transforming their whole architecture with heavy reduction of cost and increased agility. Thank you. So yeah, first of all, I would first explain. Take any software application. Take any software application. Every software application or every web app that you use daily, right, is basically composed of three components. Now you have a production presentation tier, you have a logic tier, and you have a data tier, right? What is a presentation tier? Presentation tier is basically the UI. For example, if you open Ola app, right, the UI where you can just enter your address, find the nearest cab, right? The outermost layer of any web app or any software through which you can interact, through which a user can directly interact, is nothing but a presentation layer. So the presentation layer consists of the web page, mobile app, UI, etc. Right. So before this, let me at least throw some light on what is multi-tier application. Right. So you keep there's a lot of buzz about what is multi-tier application. Multi-tier, three-tier, or n-tier has been cornerstone of architecture pattern for decades, right? And it still remains one of the most popular pattern for user-facing applications. Build any user-facing applications, it's a n-tier or a three-tier application. Although the language used to describe a multi-tier architecture varies, a multi-tier architecture generally consists of the following components, and these are the three components. First is presentation, second is logic, and third is data tier. Presentation tier I've already given a glimpse. Let me explain what logic tier is. Logic tier is basically the complete logic, in other words, the source code that's required to translate user actions to an application. For example, if you go to Flipkart, right, if you just tap on a product, and if you just tap on the heart symbol, it gets added to your wish list. So you are basically doing something, and your user actions should get eventually translated to application functionality, right? How do we do that? And your login credentials should be entered into a database. How does that happen? All these happens through CRUD database operations and data processing, right? So the whole source code that gets invisible and that helps us to basically transform our user actions to application functionality is nothing but the logic there. And third, of course, data. There's nothing without data, right? Right from the time you log in, there is your user credentials and your name, your age, your gender, your location. Everything has to be properly arranged in data. So as far as data tier is concerned, it's databases, object storage, cache, file system, etc. That whole data relevant to the application, right? So that's how it basically works. And also the multi-tier architecture pattern provides a general framework to ensure decoupled and independently scalable applications. It's no more a monolithic architecture where you completely depend on it. It's a completely decoupled and independently scalable application components that can be separately developed, managed, and maintained, right? As a consequence of this particular pattern, in which the network acts as a boundary. For example, you have to come up with a VPC subnet, and you basically have to build a network for two basic for two basic tiers to communicate. And that's how a multi-tier application often requires many undifferentiated application components. Some of these components include code that defines the message queue for the communication between two tiers, and the code that defines an API and a data model, and eventually a security related code that ensures appropriate access to the application, right? So this is the three-tier or n-tier architecture overview. You have a user-facing applications. Presentation tier is nothing but the web page or the app UI you basically interact with. Logic tier is basically the server where you host your source code. Data tier is where your data tier is nothing but the database or the or basically object storage, where you basically store your information and arrange your data into a right database. That's maybe whether it may be a relational database or non-relational database. This basically sums up the architectural pattern for a simple three-tier application. Now we have to with respect to serverless logic tier, right? First of all, the logic tier of a three-tier application or an n-tier application architecture represents the brain of the application, As I've already told, logic tier represents the brain. It's how you basically converts your user action into application functionality. This is also where the Amazon API gateway, that's nothing but the API service of AWS, and the Amazon Lambda can have the most impact compared to the traditional server-based architecture, right? The features of these two services allows you to build a serverless architecture, serverless applications that's highly scalable, highly available, and secure. In traditional model, your application could require thousands of servers. However, by leveraging Amazon API Gateway and AWS Lambda, you're not responsible for the server management. The server management is completely taken care by AWS in any capacity. In addition, by using these managed services together, you can gain the following advantages. So what's the only as opposed to the traditional model, right? Opposed to this particular model, the advantages you get is in AWS Lambda, there are no operating systems to choose, secure and patching or managing, no servers to right size, monitor or scale, reduced risk to your cost from over provisioning, reduced risk to your performance from under provisioning, simplified mechanisms to deploy, monitor and secure APIs, improved API performance via caching and content delivery. These are the advantages of the AWS Lambda and the API Gateway. One of the striking features of Amazon API Gateways, you can completely simplify the mechanism to deploy, monitor, and secure APIs, and you can completely enhance the API performance via caching and content delivery. So now comes the flagship product of AWS Lambda. What is AWS Lambda? AWS Lambda is nothing but a compute service that allows you to run arbitrary code functions. For example, you have to do a X task. For that, you code, right? And then these are the languages supported for AWS Lambda: Node.js, Python, Ruby, Java, Go, and .NET. For more information, you basically execute it without provisioning, managing, or scaling services, right? What you basically do is you are running an arbitrary code function for a particular task, and you're charged only for that function, and you're charged only when the function gets executed. If the function doesn't get executed, you're not charged, right? So what happens is your business logic goes here, no servers are necessary, your Lambda security and performance at scale, and serverless deployment and management, right? So basically SAM templates specification, SAM command line interface. So this is how things basically work, and this is and also the most popular use case of Lambda revolve around an event-driven data processing workflow, such as processing files stored in Amazon S3 and Amazon Kinesis. When used in conjunction, Amazon API Gateway and Amazon Lambda function performance functionality of a typical web service, right? It executes code in response to what? In response to an HTTPS request. Amazon API Gateway acts as a front door for your logic tier. Lambda executes the application code. So the API Gateway acts as a front door, basically, for your source code to interact with other applications, you use API Gateway. But your Amazon to execute your source code, you use Amazon Lambda. It's as simple as that. And you can see the Lambda architecture pattern, right? You have the user, and as soon as you go to web, right, there's an HTTPS request generated, and there's an API gateway at the front door, and API gateway is nothing is connected to Amazon Lambda. Amazon Lambda is nothing is connected to Amazon RDS, right? The Amazon RDS lies inside a private subnet, and this complete Amazon Lambda RDS exists inside a VPC. Outside a VPC, we have an API gateway, and the source code will be inside Lambda and gets executed inside the Lambda. And if you want to interact the source code with Amazon API gateway, you do it via this particular service. Now, Amazon API Gateway. Amazon API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs. Now, if you write a source code, if you want to convert that into an API or store it, publish it, monitor it, you get a common window where you can do everything from the AWS, and that services AWS API Gateway. Client, that's us. We that is presentation tier. We what we do is we integrate the presentation tiers with the APIs exposed by API Gateway using standard HTTPS requests, right? And another important hallmark of API gateways, I repeat again, it's a fully managed service that makes it easy for any developer to create, publish, maintain, monitor, and secure APIs at scale. It also has features and qualities that can add powerful capabilities to a logic tier, right? And another important aspect is its integration with AWS Lambda. First is integration with AWS Lambda, right? An Amazon API gateway REST API is made up of resources and methods. It has a lot of HTTPS methods. A resource is nothing but a logical entity that an app can access through a resource path. A method corresponds to a REST API that is submitted to an API resource, right? And an API gateway allows you to back each method with a Lambda function. That is, when you call an API through HTTPS endpoint exposed in API gateway, API when you expose an API HTTPS endpoint and API gateway will basically invoke the Lambda function, right? And of course, you have proxy integrations, right? What is proxy integration? It's nothing but an entire client of HTTPS request sent to a Lambda function, that is source code as it is. AWS API gateway passes the entire client request as an event parameter to the Lambda handler functions, and the output of the Lambda function is returned directly to the client. Again, what is non-proxy? In a non-proxy integration, you can configure how parameters, headers, and body of a client request are passed to an event parameters of a Lambda handler function. Additionally, you can configure how Lambda output is translated back to the user. Even that can be done. And fourth, you have stable API performance across regions. Fifth, you can encourage innovation and reduce overhead with built-in features. You need not add a lot of add-ons. And fourth, you can prioritize API security. There is an inbuilt API security feature that's given in AWS API Gateway that will also, completely will enhance your basically solution and will not let you to go to choose any other application, right? There are three general methods to add authorization to an API in API Gateway. First, you can add authorizations using IAM roles and policies. You can add authorizations to Amazon Cognito user pools, and you can add authorizations to customer authorizers, right? And now we have the data layer, right? As far as the data layer is concerned, serverless data storage options are Amazon S3, Amazon Aurora, Amazon DynamoDB, Amazon TimeStream, Quantum Ledger Database, and we have the non-server data storage options such as Amazon RDS, Amazon Redshift, Amazon Elastic Cache, Neptune, and DocumentDB. So with the combination of AWS API Gateway plus Amazon Lambda plus data layer would give you the most enhanced and the most robust serverless architecture to solve all your business problems, and thereby reducing the cost by 80 to 90%. Now let's understand what is a presentation layer. A presentation layer or a presentation tier is another upper layer is responsible for interacting with the logic layer via API gateway. I've already explained what is the presentation layer, right? Presentation layer is nothing but the web page you view through your eyes or the app UI you interact with, right? Now you basically tap something and something happens. So whatever you do, right, that's user actions, and whatever that gets translated is application functionality. For that action to get converted into application functionality, it should be coded. And an API gateway is basically a bridge. A presentation tier is responsible for interacting with logical tier via the API gateway REST endpoints. You will have a REST endpoint through which your presentation layer will interact with your logical tier exposed over the internet. If it's exposed over the internet, using the endpoints of API gateway, you can interact with the source code. And any HTTPS capable client or device can communicate with these endpoints, giving a presentation tier flexibility to take many forms, such as desktop applications, mobile apps, web pages, IoT devices, and so on. Depending on your requirements, your presentation tier can use the following AWS offerings: Amazon Cognito, Amazon S3 with Amazon CloudFront. Now let's go to another important part, sample architecture patterns, right? So what are sample architecture patterns? As far as serverless architectures are concerned, there are three popular sample architecture patterns, that is mobile backend, single page application, and microservices architecture, right? You can implement popular architecture patterns using Amazon API Gateway and Amazon AWS Lambda as your logic tier, right? Now I'm gonna explain the most popular patterns used in current software development. That is the mobile backend, single page application, and also the microservices architecture. Our mobile application, as you can view, right, the mobile application communicates with an API gateway and the Lambda to access the application data. For example, if you have showed your username and password, right, you interact with it and it interacts with the data, right? The pattern can be extended to generic HTTPS clients that are not using serverless AWS resources to run their presentation tier resources. For example, desktop clients, web server running on EC2 instances, and so on, right? Single page application. A single page application hosted in Amazon S3 and Amazon CloudFront communicates with AWS API Gateway and Lambda to access application data. In addition to these two patterns, we discuss the availability of Lambda and API Gateway to a general microservices architecture. That is the third sample architecture pattern. First is mobile backend, second is single page SPA, single page architecture, and microservice architecture pattern. A microservice architecture is a popular pattern that, although is not a standard tier architecture, involves decoupling application pattern components and decoupling them as stateless individual units of functionality that communicate with each other. This is basically how it works. So in this mobile backend, right, the presentation layer is the mobile application running on a user device, that is on your and you also have third-party providers like Facebook and Google. The client app issues the HTTPS request and includes the tokens from Cognito, you know. And then you have the logic tier, right? Complete logic tier, Amazon Gateway with Amazon Lambda. So this architecture shows there are three exposed services. First is tickets, shows, and info. What API Gateway does is API Gateway endpoints are secured via API Cognito user polls. In this whole method, users sign into Cognito user pools using their 4-head third party if necessary and receive access and token IDs that are used to authorize Amazon gateway calls, right? Each Lambda function, that is the code, is assigned to its own IAM to provide access to appropriate data source. That is appropriate data sources Amazon DynamoDB and Amazon RDS. So Amazon DynamoDB is used for tickets and shows, and Amazon RDS is used to show your information. Amazon RDS credentials from Amazon Secret Manager uses an elastic network interface to access your private subnet. Now let's go to the next important architecture called the single page application. So in this, the presentation layer is a static website hosted in Amazon S3 distributed by CloudFront. So there is a static website that's hosted in the object storage, that is S3, and that's distributed via CloudFront, right? So what Amazon Certificate Manager does is this one. It enables the customs SSL and TLS certificates to be used, right? And with respect to this whole logic layer, Amazon API Gateway with AWS Lambda, the architecture shows three exposed regions. Those are tickets, shows, and info. API Gateway endpoints are secured via custom authorizer. In this method, users sign in via third-party identity provider and obtain access and ID tokens. These tokens are included in API Gateway. In this API Gateway, right? API Gateway calls and custom authorizer validates these tokens and generates an IAM policy containing API execution permissions. Each Lambda function is assigned its own IAM role to provide access to appropriate data source. And for Lambda, for tickets, we're using DynamoDB. For shows, we're using Elasticache. And for information, that is, if your name is Shruti and if your age, demography, and everything, to show your customer information, we're using Amazon S3. Last but not the least, let me explain the microservices with Lambda. what is a microservice, right? When did the microservice architecture came into considerance? So Netflix was the first company to implement it. What microservices application architecture means is, before the advent of microservice architecture, there was this monolithic architecture where the whole application would be coded using a single code base, right? But as far as this microservices architecture is concerned, now you basically divide the application into multiple components, and you treat each component separately and host each component into a pod. For example, you take e-commerce, Amazon.com as an example. The home page is a separate microservice architecture. Your wish list is a separate microservice architecture. Your order page, your payment page, everything is a separate microservices architecture, right? So that is how things work. So basically, you divide the application and you create multiple microservice architecture. Microservice architecture 1, 2, 3, 4, right? And in this diagram, you can see there are 3 microservice architecture in one cloud account, and there's another in another cloud account, right? So it's not bound to a typical 3-tier architecture. However, this popular pattern can recognize significant benefits from the use of serverless resources. In this architecture, each of the application components are decoupled and independently decoupled and operated. An API created with Amazon API Gateway and the function subsequently executed by Amazon Lambda is all you need to build a microservice. Your team is free completely to use these services to decouple and fragment your environment to the level of granularity that you desire, because each microservices is completely isolated. Another biggest advantage of microservices architecture is you need not schedule a downtime. You can completely patch and update your application on the fly. In general, a microservice architecture environment can introduce the following capable difficulties. That is, repeated overhead for creating new microservices, issues with my optimizing server density utilization, complexity of learning multiple versions of multiple microservices, and finally, we have the serverless case study, that is Coca-Cola. So what Coca-Cola did is, Coca-Cola thought of implementing the serverless architecture into its vending, into its basic, user vending machines, right? And the way it implemented was a path breaking, right? The fact is, how it works was, when you go to a Coke dispenser machine and you order a delicious beverage, this gets, as soon as you order, it gets hit to a payment gateway, and then payment gateway via REST API call, it gets hit a Amazon API gateway, and then API gateway hits a Amazon Lambda where all the logic is handled, and then it sends a push notification to your user. So all these steps happen in 1 seconds, right? So what they did is, as soon as I order for 100 ml of Coke, I get charged $5, and as soon as I pay, it gets the complete process is now written in Amazon Lambda function, and then after I pay and the payment is successful, I get the Coke dispensed into the machine, and then push notification is sent to the user, that is me. This is how Coke completely transformed their architecture using serverless functions, and reduced their cost from 4,500 per year dollars down down from 1,300 a year. They literally slashed around 70% of their cost to this point, right? This is how the Coke was successful in probably bringing it down, because one of the biggest advantages of it is, whenever the Coke vending software is not continuously running on a GCE. Whenever I wanna dispense the Coke into a glass, the function gets executed, and only when the function gets executed is when you get billed. That is how it works. So using this complete architecture and strategy, Coke reduced its cost from 4,500 to 1,300 a year using the serverless architecture, which I just now explained. Thank you very much for this wonderful opportunity, Cloudnloud. I've been admiring you guys for a lot of things, and I also look forward to a lot of your engagement in the future, because you have a cause and you are taking a cause to another level, with these wonderful tech sessions. And thank you very much so that I could share some of my knowledge of the serverless computing, which is nothing but the future of computing. Thank you.
So thank you, Bharat, once again for a very awesome session on serverless architecture on AWS. I hope it was all very useful, guys. Now, as usual, we are going to come back to our Kahoot session. So we will be playing a game on AWS architecture. Please enter the pin by logging into kahoot.it and let's start the game in a few seconds. We'll just wait for some more players to join. Win the game, get a lot of freebies, go home happily. So we'll just wait for another 2 more minutes and see if anybody else is joining. Thanks, Shubash. Thanks, Moni, for joining this game. I hope you're going to rock it. Welcome, Lucky, for the game. Welcome, Raj. So without any further ado, let us start the game. All the best to all the players here. For those of you who have joined late, you can see the pin number being displayed on the right hand bottom corner. Kahoot.it, please log in and use the game pin 7237748. The last question for this session. So thank you for participating in this game. Please send us a screenshot of your position in this particular game so that you can win the freebies. And don't forget to send your screenshot to info@cloudnloud.com with which track you have played this game. Thanks once again. Thank you all so much. Now that we have completed it, we will be moving on to the next speaker. The next speaker is Shruti Ginny, and she will be telling us about cognitive services and throw us some light on some insights about it. Welcome, Shruti. Welcome to the session again. Over to you.
Hi, this is Shruti Jigini from Cloudnloud Tech Community. Today I've come up with an interesting topic, and yes, I'm going to talk about Azure Cognitive Services. Before I go ahead with my topic, we have come to an end of this conference, and I would like to thank each and every participant who have actively participated in today's conference. I'd also like to thank all our speakers without whom this conference would not have been successful. And last but not the least, I would also like to thank all the committee members, the active members of Cloudnloud Tech Community for trying themselves from a couple of days, to make this conference a successful event. Before I go ahead with my topic, I just want to tell about my community, which I love to be a part of. And yes, I'm talking about Cloudnloud Tech Community. Cloudnloud Tech Community was a dream of our founder, Vijay Balan Balakrishnan, who founded it 11 years ago with the dream to serve cancer children, help them with the medication as well as education. And by now, he was successful in providing medication for around 6K children and education for the children post their cancer treatment. And we have been conducting a couple of Q&As, tech talks these years, and we are happy now that we have come to a point that we made this conference a successful one. Okay, then I think it's time. Let's talk about our topic for today. And yes, Azure Cognitive Services. And when we talk about cognitive services, the first thing that triggers is it revolves around the artificial intelligence and machine learning and deep learning and so on. But okay, let us go one by one and try to understand what is artificial intelligence. What is artificial intelligence? And so our agenda would be like, first we'll try to understand what's artificial intelligence, so how it's going to work, so where it is used, and I'm going to give a scenario like how the this scenario, how cognitive services help to solve this scenario, made it easy. And then I would like to pick up a topic, a project which I done in my back those days in my MCA, of predicting a student dropout analysis. And yes, with that, we will quickly go jump into cognitive services, understanding various services under Azure Cognitive Services. And I think with the at the end of this session, you will have some good understanding on cognitive services and why they are so important, and they have been part of our part and parcel of our life in our day-to-day life. Okay, let's next move on to next slide. So let us understand. So what is an artificial intelligence? So it's nothing but it's a simulation of human intelligence processes by machine, probably a computer system. So what it includes is it includes all your expert systems, natural language processing, as well as the machine vision. So now let us try to understand how does AI work. So basically, it requires a specialized hardware and software, for training and writing a learning algorithm. And we use mainly the languages we use for this is around R and Python. And so what AI mainly focuses on is it mainly focuses on the learning, reasoning, and self-corrections. So this is the main areas where AI cognitive. I mean these AI focuses on. These are the three main cognitive skills which the AI focuses on. Okay, and next let us try to understand where it is used. Yeah, so mainly first it is used in automations, obviously, right? So so for automations, when it comes to automations, like when you pair it with the AI technologies, you can expand the volume and type of tasks that you can perform. So the best example is RPA, that is robotic process automation. So that's the one, and probably you're using it in a machine learning. So the deep learning which I was telling you about, regarding so what it is done is it is a science of getting your computer system to act like you're not used without any programming language. So it's in science, or it's a science of a what to say, you're getting your computer to act without a programming language is machine learning. So deep learning is a subset of machine learning. Okay, and then this machine vision means what it does is it captures and it analyzes the visual using camera or and digital signal processing and also this is this way. And then you have self-driving cars. So what it does is so autonomous vehicles, they use the combination of a computer vision as well as image recognition and deep learning. So these three things, like computer vision, image recognition, and deep learning, to build an automated skills. So these are the main areas where AI is being used. And now let us try to understand a scenario. Yes. Yeah, so you can see in the pic, for example, I'll tell you one scenario. Okay, so consider, okay, so you are an app developer, and you've been given and you've been told that you need to develop an application such that it is going to take an image as an input and it is going to identify the gender, pet faces, like that. Now for this particular the thing, like this understand this what this the how will you give an output? You will have to have some knowledge on a deep learning. You need to have some knowledge on R as well as the Python, right? So this is all you know. You need to understand all this. Now, this is again a time consuming, isn't it? Now, what would I say that you are using a cognitive services and trying to solve this problem in a very simple manner. So yes, it is possible. So this is where, cognitive services help you a lot. So what is the cognitive services basically? So it is nothing but it is a set of it's a set of APIs and you know the it's a set of APIs and toolkit to develop intelligent applications. And without a knowledge, like you need not have a knowledge of a deep learning, or you need not be, good at your hand. You need not have your hands on, R, Python or something. But just what you need to do is you just need to give an API call from your application to a custom vision API of Azure, and that's it. That's it you need to do, and that is going to identify for a given image. If an image is given as an input, it is going to identify whether in an image, if there are humans, there are any pet animals like there's a dog, cat. So just you need to pass this. That's it. So this is how, I just wonder how, cognitive services is helping out a lot. So I thought, like, back in my MCA days, I did a project on, a student dropout analysis. It's a prediction wherein, so there's like the educational institutions, they will have a lot of things like, they have a lot of competition, cutthroat competition for the admission process. So they need to maintain a standard with academic record as well as pass out rates. And the situation is like, when a student is going to enroll to a program, he may drop before the prescribed program. For example, he has taken his admission for a BCA. So it is not a thing that he is going to be there, he's going to study for next 3 years. He might drop at any point of time. But they have not, like, this has been happening at institutions, but there was no research, proper research done on why students are dropping. So how we are predicting it? Okay, this guy is, you are taken this, okay, the few of the parameters that this is going to happen, this is, yes, he has this issue, no, he is not having this issue. Then you're predicting that yes, he will drop out or he will not drop out, so that you can come to a conclusion. But how that is going to happen? So how I worked is like, I had worked it with my professor, and so there is a period that so the student may drop for a lot of reasons, probably for an economic, financial loss to institution, or student may have multiple reasons like, domestic problem, competitive stress, family, peer pressure, lack of advising, and probably like they have come out from their place, like they stay in PG or whatever and paying guests, or they're not able to adjust to the climate, or homesickness, or educational burnout. Probably that was not their cup of tea, which they wanted to do. So those are all the cases, they might have, might drop. So then we thought, like, why not we are going to take this as a scenario, and we will do some prediction on it. And then what we did basically is, like what used to happen is, like, institutions may just record student dropout. Okay, this person dropped out, but they probably most of the time they will not be knowing, like, what's the reason they have dropped out. So that analysis will have not been done. So there will be a lot of admissions and dropouts that keeps happening, every year. And so we thought of developing a model So what happens is, like, what I did, like, we charted out few of the questions, and we did two kinds of survey: a pre-survey, post-survey, in two phases, phase 1, phase 2. Two surveys, like one before he's going to, like, at the time of admissions, they will be given the survey, and they will be requested that their data will not be revealed, and they have to give an honest reply to it. They will have filled all the details. And one at the time, like when they are half away in their education, this thing semester, we would have taken their second um, uh, second survey, that is phase 2 survey, post survey, to understand. And these two things, what we did, we tried to apply the navigation algorithm. Probably few of the, that sounds technical. That's fine. So we tried to apply the navigation algorithm, and we tried to analyze, like, predict what is the percentage of people who are going to drop out. Okay, so then so the main thing is, what we did is, the flow was like, first we will do a pre-survey, then we do a post-survey, then we will do pre-processing of the data, whatever we have received, that pre-processing, then we'll convert that data to CSV, then we load them to R, so R language for PC analysis. And then what we'll do, we'll extract that output to visualize. Then we will generate some vector values, and then we are using some classifiers that, with these scenario, that, whether, like, he is not getting adjusted to the climatic condition, he had an educational burnout, he has not he has a domestic issues. So these are the scenarios. Then yes, this guy is possibly going to drop out. So that is how we tried to predict. So what we understood is, what we did is, we analyzed this dropout accuracy through Weka. So we implemented in R, and we were able to predict, like, how many were able to drop out. And that was, it was a very interesting project I did. It was fun, actually, doing this project. We had to go to couple of classes, get their data, and that was fun. Data is always fun to work with. And yeah, I just thought to, tell a few of the points regarding the project. So I just remembered when it came to, machine learning. And yeah, so next thing, what I wanted to tell you is, yes. So what is Azure Cognitive Services? So I have already told you how the cognitive services help to, get our work done. So in Azure Cognitive Services, we basically have 5 kinds of services: vision, speech, language, knowledge, search. Let's try to understand each of this one by one. Okay. So how it is going to work is, okay. So vision, what it does means, it refers to an application which is capable of identifying and analyzing the content with the help of videos and images. For example, say a scenario like, a people are waiting for a metro train to arrive. Now this is the data. This is the scenario. Now what it does is, this particular service, what it does, it classifies the visual elements, like, for example, people waiting, luggages, women standing. So like that, it will classify the visual elements. And that is the work of, the vision service in first service in Azure Cognitive Service. Then is speech. Okay, so it's regarding natural speech, recognition engines. So we basically have speech recognition and speech to text transcription, text to speech transcription, speaker verification, and those services are really there's if you have a day to tell, I think you have a lot to talk about this stuff actually. And then is the third service, that is language service. So it is nothing but we need to understand that a language and the context based meaning. So they are the two features that describe communication. Okay, so the main example you can take translator text or content moderator. So based on that, it is going to identify. And next best example, and next service is the knowledge. So what example I could give you is Azure Q&As. They're so powerful that they can whip database in seconds. For example, if there is someone asking how can I log into this page, a particular page, how can I log in? So to say that use your X account to log in or something like that. So it will immediately give you the response. So that is the uh, uh, basically that is the power of Azure Cognitive Services. And the last service under Azure Cognitive Service is the search engine. Now you know that Bing is the popular one. When it comes to a popular one in Microsoft, but yeah, I do admit that it is not as popular as Google. But to be honest, that they have very good powerful AI powered algorithm. So that is it is capable of searching, comparing the results, and summoning everything. So it gives you a relevant this thing search based on inquiry. So it's very powerful to say, but it was not as powerful as your what Google search to say. So these are just the 5 services. They are very important that in Azure Cognitive Service they are they are the 5 different services. And if I could take some example that how it so there's a best example if you want me to take. I would say an example of Netflix. Okay, so in Netflix, what happens is, so Netflix is nothing but it is an online movie rental service, right? So what it does is it uses machine learning to predict which movies customer likes. Okay, and that's what. And another example I could give is internet business, that's eBay. So it uses the machine translation to enable users who search in Russian to discover English language listings. So that is one major advantage. And one thing these examples have in common is that they encourage greater use of the service, and that's all the credit goes to the Azure Cognitive Services. And I hope I have given you some thoughts, some ideas on Azure Cognitive Services, and I think it was kind of useful, and you have got enough insights on it. And thanks for your time. Good day.
Thank you so much, Shruti. It was very nice, and you had given a detailed explanation about Azure Cognitive Services. So now let us also play one more game with respect to Azure. I hope you guys are having a nice time. Please let us know in the comment section about how good the sessions were. Now we are going to start our session in Kahoot again with Azure Biceps Deep Dive. So without any further ado, let us start. Once the game pin is loaded, you can go to www.kahoot.it, log in with the game pin, and let's start playing. Welcome Ramakrishna, welcome on. We'll just wait for a few more minutes and see if anybody else is also joining. Once we have our team, we'll be starting the game. All the best to all of you. I hope you get some goodies and freebies. So we are starting the game now. The last question for this session. So congrats to all the winners. Once again, a gentle reminder, kindly take the screenshot of your screen and send it to info@cloudnloud.com in order to get the freebies and goodies. Congrats, Lucky, congrats. So now that we have completed one more session, we will be deep diving into another session. This would be from Neha, and she would be talking to us about unit testing without writing any use cases of mocks. So welcome Neha, the stage is yours.
Hi folks, I'm Neha. This is Shubham with me. We are the maintainers of 𝒂𝒚. That's an open source API testing platform to generate test cases out of API calls along with the data mocks. A little bit about ourselves. We have both been leading previously data team at FARI and special projects team at Lenskart. We have been contributing to open source world like projects like XWiki, Jenkins X, and why we started 𝒂𝒚. I'll just give you a brief story that we all have been in this state where we wanted to start something new, make some new project, make new features, deliver those, and we wanted to do all that fast. And as the code grew, the effort of writing the unit test cases, the API test cases, it became difficult. Maintaining those unit test cases took a lot of bandwidth, and we all ideally want to achieve more than 80% of the test coverage, but the time is limited. Especially when I talk about writing unit test cases or API test cases in terms of microservice environment, then you need to write a whole lot of data mocks. Let's say your service is talking to some internal microservice or third-party vendor service like Twilio, Stripe, some Google or AWS microservice. Then you have to really write a lot of data mock, dependency on other teams, a lot of bandwidth. So yeah, all that was very frustrating, and we all wanted to shift a bit left, wanted to discover all those bugs as we are developing the application just during that, because as that bug floated towards the right in the software development lifecycle, this is a very popular saying that it costs you exponentially, both in terms of money and time. So yeah, that's why we started keyploy. So how it works is very simple. Whenever you're making an API call to your application, keyploy SDK is just going to record the request, the subsequent network calls from the third-party vendors or DB services or any other external dependencies, and the expected response for that API call. It's going to combine all that and gonna save it as a test case in the keyploy server. Next time, whenever you develop a new version of your application, you just run the application in the test mode. Keyploy is going to download the previously captured test cases and run it one by one with your application. And the cool part is that you don't need to set up the dependencies, those external dependencies, like let's say you're using MongoDB, Postgres database, or you're using a messaging service, anything, payment service. All those does not need to be mocked while testing, because keyploy is just going to mock that from previously recorded network interactions for that API call or a test case. And whenever your new version of the application is going to return a response, keyploy is going to match that from the expected response and going to highlight what all impact areas are there, if any. Yeah, so that's how it works in simple terms. A few different features from traditional record replay products is keyploy is able to find the non-deterministic fields, like in your APIs you might have timestamps, random numbers, UUIDs, etc. So keyploy is able to remove those noisy fields and does not highlight that while comparing your expected and actual response. And like we just discussed, we are not only replaying the API traffic but also the external dependencies or the data mocks that you write. And last but not the least, we integrate with the native testing libraries. For example, in Go, we integrate with GoTest. So that will benefit in the case like you don't need to modify your existing CI pipelines if you are already tracking coverage with GoTest, and you don't need to you don't need to remove the existing unit test cases and record it via keyploy. It is written or integrated in such a way that you can use keyploy alongside your existing unit test cases, and it will show the additional coverage with the existing unit test cases. And one other benefit that you get with it is that you can use your existing tooling IDs to see which areas of the code are covered or not. So Shubham will quickly show you a demo around this, how to quickly capture the API calls into test cases, replay them for testing purpose, and how to track the coverage. Shubham, up to you.
Hi folks, so this is a demo of keyploy. So here we'll be exploring a sample application to show what keyploy does. To get started, you can head over to the keyploy GitHub repository. So there's the main keyploy page. And to install keyploy, currently we provide two options. You could either use the Docker Compose to quickly get started locally, and later you could also use the Kubernetes Helm chart. So for the purpose of this demo, after we've cloned the keploy repository, we can just simply use the Docker Compose to quickly get started. So let's do that. Yep, once this is done, we should have keploy started. I can check out the UI on localhost 8081. So as you can see, there are two sections here, test cases and test runs. Currently, test cases and test runs both are empty. Next, let's head over to the sample application. So in this case, it's going to be in keploy. We currently have a repository for our Go samples, which is samples.go, samplesgo. And since currently we only support the Go SDK, we have a sample repository for that. We also are working on a JavaScript, Java and Python SDK as well. So if you are interested in those SDKs, feel free to join the community, and we can work together in building a great SDK support for your application. So for getting started with the Go, a Go sample, we'll check out the Echo SQL sample, in which we're using the Echo router and Postgres. And in this example, this is a URL shortener example. So in which there are just two simple endpoints. The first endpoint would shorten a given URL, and then the next endpoint allows you to get back the original URL. So it will redirect to the original URL from the shortened URL. To get started, we already started keploy. Then we have to clone the URL shortener and start the Postgres instance. So let's do that. So this should start the Postgres instance, and then let's head over to the URL shortener code base. So in the URL shortener code base, it's a pretty short code base, and here we've already integrated keploy. So you can see here that we have initialized keploy, and we have to supply the application name, the port at which the application would run locally, and as well as the backend configuration. Now, since we are running locally using Docker Compose, this is the default endpoint. If you don't provide any endpoint, this tries to connect to the keploy's production endpoint. So keep that in mind. If you want to use the managed service, you could use that, but you would need an API key by signing up to the console, or you could use your own by running your own keploy on your own Kubernetes cluster and passing the URL here. So while you initialize keploy, you also need to wrap your dependencies and your router. So in this case, we're using the Echo router, which is pretty popular. So here we're adding the middleware for that, as well as since we're using Postgres, we have a way to quickly wrap the SQL driver and register keploy's driver. So here we're wrapping the driver. KSQL is keploy SQL package, and here we are registering it. So 2 extra lines. And yeah, this is how we integrated keploy into this application. So this is just one-time setup during initialization. Every other call would not be required. So once this is done, it's time to run a URL shortener to try it out. So let's, we're using hopscotch. You could use curl as well. So let's try. Let's give it github.com instead of google.com. Send, and we have a shortened URL. Now we can take this and just do a get. So as you can see, this source code is essentially GitHub source code. So if I paste it on the browser, it would just go to github.com. So we can see the URL shortener is working. Now time to see what keploy generated. So now if I head over to test cases, I can see it captured all the 3 calls that I did. I can go into the details. For example, here's a response, the response headers, the request, this was in the body, the request headers. And here's the interesting part. We also get a section for dependency. So what makes keploy special, compared to other regular record replay products is we also record the infrastructure calls. So this helps with the dependencies. So in this case, as you can see, during these calls, first there was a ping operation, then a query context, and I can see the exact queries which are fired with the arguments, right? And you can also, if you're a power user, there are many things that you may not find in the UI. You can dig deeper using the raw events. So this allows you to go deeper into what keploy is doing without being limited by the UI itself. So as you can see, there's another interesting thing is that it has already figured out that body.ts is noise. So as you can see, in the response, the timestamp field will always be different. So keploy is already figured out to ensure that in future comparisons, avoid timestamp file comparing, because it will always be different. So yeah, that's how we figure out noisy or non-deterministic fields. Now as you can see, test runs are still empty, so we'll have to perform some tests. So now that test cases are recorded, I can head over here and we have a native integration with Go test. So all you need to do is just add these 3 lines and that's it. So let's try to run that. So I'm using IntelliJ, so you can quickly run this with coverage. So before that, let me stop deploy. Sorry, the URL shortener demo. And yeah, the interesting thing here, we mock the dependencies call. So remember the Postgres that we were running? We can actually stop this. We don't need this running anymore during testing. So let's stop it, and let's run these tests. So as you can see, there's a configurable cold start period of 5 seconds, and as you can see, it is downloaded and run 3 test cases. All of them are passed, and we're also getting a coverage because it integrates with GoTest. You can also see GoTest allows you to see test coverage, and in this case you're able to see the test coverage in the IDE itself. So for example, if I go into main.go, I can see what lines are covered, what is not. You can see the red and yellow and green lines showing you which lines are covered, which are the conditional statements, and which are not covered. Same here, like you can individually go and see. This will help you. For example, this line is not covered. You can add a condition, or you can you can create an API request which will cover this, right? So this helps you get deeper insights into your test cases, similar to what you would do by writing a unit test, right? So here I didn't have to write anything. I just recorded what I was, what I would do as a developer, and I have already got 76% coverage. It's a simple code base, but I think this gives you an idea of how you could quickly unit test your APIs and predictably run those test suites without needing to write mocks or test data or explicit unit tests. To go further, what we can also do is we could try changing behavior of the application. So in this case, or in fact, before that, let's quickly see if I want to deep dive into what's going on. Now if I go to my test runs, you can see there is a test run which I just ran, and you can see there are 2 endpoints, and it's showing me like this was just a redirect, so there's nothing here. But in this case, I can see that what the expected actual response is, and like I said, timestamp is already identified as a noisy field. So as you can see, these are different, the timestamps are different, and keploy did not fail the test case. It was like, it's fine. Now let's try to fail a test case. I think that will be more interesting. So to do that, we can maybe change the key that we're returning. So for example, from something like URLs to URLs. That should simply allow us to see a change. So let's try to rerun the test cases again. Cool. So we can see that one of the test cases has failed and the overall test suite has failed. So let's check that out on the UI. Yeah. So as you can see now, there is one failed test. If I open it up, I can quickly see that keploy has identified that this has been removed and this has been added. So it has spotted that there's a change. Now, this could either be a regression that is added by you, or this could be an expected change. And again, I'll talk about dependency mocking once again, that you know you're not running the Postgres anymore. So the whole um, um, application thinks that it's talking to Postgres, but it's actually getting all the data from Keploy using the SDK. So that's a great part. You don't need any infrastructure anymore while running your test case. And if I want to consider this as my new default, all I need to do is I can normalize it very easily. I can go here and accept this as normal behavior. So what this is going to do is that it's going to update my test case to use the newer responses. So again, I didn't have to write anything, and I've updated my newer behavior. In fact, now if I go to my test cases, if I refresh, I can go in here and I can see it say URLs. And let's try running tests as well once again. So if I run the tests here once again, you can see all tests are passing, because I can see that in the UI as well, that it's now expecting the field to be URLs. So we've kind of, as we're developing, we've normalized the behavior based on what we expect from the application. Yeah, so I hope this gives you some understanding about Keploy using a sample application. You can all try this by going over to the sample repository for Go, which is available. And one fun fact which I would like to also talk about is how we're also testing Keploy using Keploy. So for example, the 74% coverage you're seeing here, we have not written any unit test. It's all using Keploy. And in fact, since we were using Go test, we were able to reuse existing tooling. Like for example, in this case for test coverage, we are using coveralls. You could be using any other test case coverage product, any other CI product. So in this case, we are using GitHub Actions. So you can also go here and look at the workflow. And this is the test step. And in this particular place, like this is the standard way of testing a Go program. There's nothing special related to Keploy. The only thing that we have done is added few environment variables. This one is for the API key, which is in this case the API key for the open source project. It's a public API key. And also we've added a flag for deduplication. That's it. If you're using your own hosted version of Keploy, even these will not be required, and you can simply use whatever Go test pipeline you already had. And another interesting thing that you can also do is, let's say you already have existing unit tests already written, right? Maybe your coverage is maybe 50% already. So Keploy's test would run alongside it, and whatever it's adding, it will add up to your overall coverage. For example, let's say you have 50% already written and additional 20% is covered by Keploy. Go test would start reporting 70% coverage. So that's another great way to integrate Keploy into your workflow. Yeah, I think this gives you an understanding better about how you can integrate Keploy into your workflows, into your CI pipelines, and leverage it for saving time in managing your test data, writing test data, writing mocks, which can be super painful, especially if you have a lot of internal or external microservices, and also writing the tests themselves. So I hope that gives you an insight on how you can be more productive there. And yeah, that's it for the demo.
Thank you so much, Shubham, and thank you, Neha. That was really an awesome explanation. We hope to see you with more such videos over here. And once again, thank you all the speakers, Yasmin, Shruti, Neha, Bharat for giving us a lot of informational stuff about Azure, AWS, cloud, unit testing, and much more. Guys, do watch out our other parallel tracks that have been happening since morning 9 a.m. IST with various speakers like Ryan O'Connell, Satyen, David Das Nevis, and much more. We have many topics covered from Terraform to Ansible to Azure to AWS and DevOps. So don't miss out. And I'll sign off with a note about Cloud and Low Tech community. And we would also like to inform you that as new trends are developing and unexpected changes are occurring, what we know is not what matters. So it is all matters is how quickly you learn, unlearn, and relearn. Since the future is very unpredictable, and as a community, we are remaining agile and relevant, not just with the up-to-date recent developments, but also preparing for the future as well. We will be giving you a deep understanding of more such videos and more such topics in our upcoming conferences, hackathons, and technical events that will be happening in our LinkedIn, YouTube, and Facebook. So don't forget to stay tuned to us. Thank you once again. Thank you all the speakers and a sincere thanks to the organizers and the community for hosting such a nice event. Thank you guys.